extremely happy to launch the 2021 Inside Tech Talks NYC. As I say, I'm also extremely happy that I can do it safely from the basement of my office building, which is a high-tech wonder. Was built in 2017.
So Murad, I have a question. Are you an investor and/or shareholder in Cubico?
No, I'm not.
I'm just checking, man, because you're making a great pitch for that office space, and it is, by the way, for those who don't know, it is really nice. But
I won't say this out loud, but I bet there's a deal there to be had in COVID world to get in as an investor at a reasonable price. But that's another matter. Anyway, thank you for everyone who is joining, who has joined. We are going to be launching this series as a format, basically for emerging technology. That's the way I've sort of explained it in the foreword of the Inside Tech Talks website. Emerging technology, in particular, of course, in the software industry, things that are happening in the software industry that are at the cutting edge, at the bleeding edge. Folks are building stuff as they build the road in front of them. That's definitely happening in these two companies that are going to present today, CodeLogic and Kleeen Software. These are the types of technologies that some folks haven't even seen yet. And that's the real cool part about that, is that they're being introduced into the marketplace. You're not going to see this from Microsoft. You're not going to see this from even some of the other major or minor or recently launched companies. This is all brand new stuff. I hope I can do that on an ongoing basis, on a continuing basis, bringing emerging technology to all of you each time out. And I'm going to try to keep a cadence of monthly events. I have some compatriots who do this extremely well in New York City. I kind of learned the trade from my compatriots who do these meetups in New York City. Folks, some of you know these folks like Alex Dubovoy and Melissa Iden, Masha Danilenko, Masha as well. Masha unfortunately had to go, was pulled away from New York City by Facebook and had to go to the West Coast, and Facebook basically told her, hey, I'm sorry, you can't do this anymore. You can't do Inside Tech Talks anymore. So she was kind enough to give this over to me to move forward in NYC. So that's what the broad brush of this event is, and it will continue to be that way every month. Without further ado, let me introduce the two speakers from the two companies that are coming on today. We have Ned Dichtel, the CTO of CodeLogic, and we have Matt Fox, the CEO of Kleeen Software. Ned has a long history with computers. He started with the Commodore 64, that's home computer.
Nope, that's not correct.
Not the one.
My VIC-20 sitting right back there. So
VIC-20, impossible.
What about the abacus, man?
The funny thing is that as a kid I had an abacus. I however have to profess I never really did learn how to count properly.
Well, I'm trying to introduce you, but now you're segueing into a whole different story.
I will be quiet and let Matt introduce himself. Matt and I know each other from other venues.
Anyway.
Guys,
we have Ned and we have Matt today. Ned is going to lead off. What I'd like to say is that we have a flexible meetup today in terms of audience participation. However you like to ask questions is fine by us. Whether you wish to put it in text format in the chat, we will be monitoring the chat regularly, or you want to raise your hand or you want to say it out loud, can I ask a question? Please feel free to do so. Ned actually, often does stop in the middle of something and says, does anybody have any questions? So that's kind of the ambiance we want to do. We want interaction, we want talk, like live talk. The more live talk, the better off this video is going to be, so to speak.
Well,
anyway.
Hopefully we also show some technology too. I mean, I can just talk if you want. That's cool.
Yes, we're going to show some technology, and that's going to be the best part. Off you go, Ned. I give the floor to you.
So there I was thinking, let's get going, and now I'm not quite ready. So give me 1 second here. I'm going to get this.
Can I ask a question?
Sure, please.
Murat, is there a fireplace behind you?
Yes, indeed. Well, I was explaining this early on. This is a gas fireplace in my basement in my office space. And as I was explaining to folks, this is the whole basement area that we.
Oh, no. I was just wondering if that was a video or a real gas fire.
You know what? I had the exact same question. So thank you for being the person to ask it, because I couldn't tell from the little window that I have on the screen whether I thought he had to. I thought it was a live stream.
It's like having a Yule log video.
We do have all of those, but not only is this a real gas fireplace, but it's warm, and I'm gonna have to, start taking off my shirt.
Whoa!
We're gonna watch it.
Let's not go too far there.
All right.
This is rated G.
I'll just roll up my sleeves. How about that?
There you go.
All right, we'll behave.
All right. So with that being said, thanks everyone for joining. My name is Ned Nichtel. I will keep this very short. I'm the CTO of CodeLogic, and been in the industry for about 25 years. I'm joined, by the way, on this call by my co-captain and chief software architect for Crosscode, Mr. Brandon Tilkey, who is a very sharp guy and is probably going to pull my butt out of a sling multiple times this evening. Essentially what I do is I head product development delivery, which sounds much cooler than it really is. My background is in operating systems internals, cloud software architecture, data modeling, SCAR analysis, and that sort of thing. So I'm pretty like to get into the weeds, and well, this kind of product is kind of, you have to build it in the weeds, so to speak.
But
prior to this,
whack the weeds.
Hey, it's a funny thing, but there was a guy outside, speaking of which, today, like in 22-degree weather with his weed whacker. And I'm thinking, is that really necessary at this time of year? But yes, our job is essentially to try to bring some order to chaos, or I shouldn't say necessarily bring order to chaos, but let you see what needs to be done, so you know where to use that weed whacker. And we'll talk a bit about that, because we ourselves fell victim to many of the problems in the first revision of this code base that we built, a code base that Brandon and I inherited, and then we started over from scratch. And it's an interesting story, and it'll sort of illustrate that whether you're a small company, a large company, a small team, a big team, the problems around both at the micro and macro level, the issues with dependencies and understanding them all up, especially in an as deployed state, is really a big issue. So really quickly, I'll just describe what it is we're building before I get into things like use cases and sort of all that jazz. It is in effect a directory of dependencies. So we're not just about showing you an application or showing you a module. Our goal is to show you from all the way from, as I say here, method and column, all the way up to platform. And what would platform to platform be? Well, platform might be, for example, an infrastructural platform. It could be a platform like ServiceNow. It could be, the way we look at it is, if it's related to running code, if it supports running code, if it is running code, it potentially has interesting dependencies and relationships that need to be understood, because in reality, all this stuff tends to interact and be intertwined. And it is pretty interesting once you start to look at both at the lowest levels and up all the way to the top levels, the sort of fascinating, well, we certainly have some real problems in the industry, and we'll illustrate more at the microcosm tonight. But it's pretty easy to extrapolate out what happens when you connect the dots across multiple applications, multiple systems, and so forth. So what we're trying to cover are application internal dependencies, microservice dependencies. So when you think about microservices and sort of domain-oriented architecture and domain-oriented programming, it's a wonderful world, and it definitely has massive benefits in terms of having tightly scoped and defined services that are hopefully, if done right, as small and compact as possible, with very well defined principles regarding, for example, separation of concern and so forth. Problem is that, and I learned to learn this the hard way, microservices get abused. You think you have one sort of central routable API and things are supposed to talk through a common set of interfaces, and before you know it, somebody says, it's too hard to deal with that because that likes to check, for example, security references and all that. So I'm just gonna call that other service over there directly, and all of a sudden you start to have, instead of a nicely defined architecture, suddenly things start to get very ugly. And microservices, unfortunately, are prone to that unless you've got really, really strict discipline. And unfortunately, even in places like the last company I worked at, which was MindStack, we had very strict discipline, but we still saw problems around that. Data storage dependencies, infrastructure, inter and intra-platform, all that stuff, eventually up to business process. And we're not there for all of this yet, but this is where we're going. And the intent is that all of this is wrapped with auditing, governance, and alerting based off of governance, and soon predictive analysis. And predictive analysis means that we take all this interesting data that we're gathering and we say, hey, we got this. Can we analyze this to see bad patterns or problems where you might want to take action? And that action could be as simple as putting a governance rule on a particular data element in a database. So it could be a column, it could be a whole table, or it could be a particular base class. And that, for example, this base class deals with certain types of data manipulation that are used in your code base for sensitive pieces, and you want to know if there are new instantiated instances of that class popping up, that sort of thing. So why do this? Why tackle this problem? Just a couple of quick examples of what is happening in the industry from our point of view, and it's sort of what's driven us to build this product. Our CEO, Greg Wonderly, always asks this question of, where do you start? And if you can't answer that question, you very quickly get stuck in the waiting place. And that's what this snippet here from Dr. Seuss is indicative of. If you can't address this, it's a really big problem. And so what kinds of things can land you there? Code refactoring or rewrite. This is one that's plaguing the industry, I think, in a very big kind of way at the moment. A lot of code out there needs to be rewritten. There's a lot of it that just, we sit and we refactor, and maybe we do these, partial things where we start out to sort of go and decompose some monolith and move it into microservices or something like that. But it never really is approached as an all up, nope, we need to restart because this is not worth doing in some piecemeal way or in some attempt to salvage what's there. And usually that means looking at the architecture all up. Another one is migration and upgrade. When you start dealing with even a single application where there's dependent services and other elements surrounding it, especially other applications, you run into this situation quickly where you don't really know how far that spider web extends. And this ends up becoming an extremely manual process to go and figure that out. And then problem solving, same sort of thing. You deployed an application. This is one where we're working on this scenario right now in the ServiceNow space, wherein you have these wonderful tools that help the IT operations side and such understand that these applications are getting deployed. It's tied up in orchestration, which is backed by the DevOps pipeline and deployment pipeline and all of that. But then you get to this point where the app gets deployed, something didn't work, application's got some subtle problem. Now you're getting calls from from everywhere in many cases. And it's not clear on how you're going to even go about unpacking that. So a lot of this is about stopping the madness, right? Unmonitored and unknown dependency changes, architectural problems, honest mistakes. This is, by the way, we've dealt with in our own experience. We've dealt with all these. So here at our own company. And in terms of our current product, we've used it successfully to deal specifically with that third one, while it keeps us honest about the other two. And that's part of where we're going. It's as much about helping you address the problems of today, but also preventing them from reoccurring, because that's sort of where we really need to get to. We shouldn't be blind as to what's happening with all of this. So, if you take a look at sort of the now, and then you look at what we're trying to get to, you can kind of see the what broke, who's the owner, identify changes, what got deployed. Then you have to go over, review the source, trace dependencies to app that actually broke, because that's a big one, right? Anyone here ever had that where, you know, the app that's lit red on the dashboard is not the one that's actually broken? But a subtle change somewhere in the last 2 months when caused the breakage to occur. I love the latent breaking. That's the one I love, where it's actually broken here, but it doesn't show up till something got fixed over there, but it now looks like this was the thing that broke. So, you know, this is a big mess. The idea that we're trying to get to is, you ask that question, and it could be any of those other ones I mentioned, but what broke? Review the audit history, do an impact analysis, correct the impacted components, set a governance rule so that in the future, when someone goes messing with it, you get a notification around whether there's a new dependency or something changed with that dependency, and so forth. And finally, just on the subject of security, we don't consider ourselves to be a security product. There's a lot of very, very excellent tools in that space. But the core principal issue around S3D, meaning secure in design, secure through development, secure through deployment, you know, it's very hard to claim truth around any of these, I think, in the current world. If you don't know the real current architectural state, or if you aren't tracking these unknown dependencies and getting them to be known, if you can't stop dependency issues and code changes and other things from impacting deployed state of one or more applications, boy, how are we claiming that we've got a handle on this? And I think the truth is we keep seeing problems out there as a result of that. So where we're going through this quarter and into next quarter is starting to analyze the data that we're gathering as we start to deploy and work with customers in their environments, and trying to recognize problematic patterns, because there are interesting patterns, and you'll see in a few minutes when we show you. We're going to show you what will look like the most ridiculous thing you've ever seen, but in fact only comprises just a small subset of an application. We need to be able to see these problematic patterns and subsequently connect the dots to them, and most importantly, start giving some proactive guidance. Or if it's reactive, it's something where it's emergent, where you didn't see it, but we did, but there's an emergent issue. And what we mean by emergent issue is, well, you've got an architecture that is prone to these types of abuses of dependencies. So wrap some governance here, wrap some governance there, so that you can at least start getting notifications around these things as the application and its dependencies and so forth evolve. So with that, I'm going to skip over those slides. Before I go any further, I will ask if anyone has any questions. And I'll need some help from whoever's monitoring the chat side of it, because I don't have that up and running.
Yeah. So, well, I guess you'll be showing it. So how are you actually discovering all this stuff when there's all this complexity?
Well, Matt, it's funny you should ask that question. There's not one. I'm going to table that, because that I wish I could say that's a simple thing to answer, but unfortunately it most assuredly isn't.
Yeah.
Whoops, almost went to the wrong thing here.
I remember I worked at a company that, you know, we had all this stuff. It was a while ago in Siebel, but we'd push it through Lotus Notes and then into a spreadsheet. And you just see all this hacked together stuff in big enterprises where it's like, wow, yeah, you don't even realize all the, all the crud that is put together.
Well, you know, I know what you guys do, and you know, I think one of the interesting things is the space that you're in needs the things that you guys are building in a big kind of way, because it's sort of analogous to the problems that we're seeing out there, because there isn't good standardization and practices around a lot of especially rapid application development, right? So you see this happen, and by the way, it's just absolutely endemic. It's just a crisis in the JavaScript world at the moment. It's gotten so out of control. And you know, I know from our own experiences with JavaScript and our front end that, boy, oh boy, I got to tell you, I can't think of any language that needs sort of structure and controls wrapped around it and following standard patterns and models, you know, this sort of MVC type model. That being said, yeah, I think when you look at the application situation, it is absolutely very serious. And we talk about that waiting place, you really see that I think in the enterprise very significantly. What you see in smaller teams, you know, companies, you know, our size and such, is you see the problem beginning to evolve. and you see the time lost because of work that really wasn't very good, and you don't know how to quite unhook it and decompose it. So, but it's happening at the small, it's happening at the big. You know, it's the bane of every developer's existence. So with that being said, first off, I just want to check the chat real quick. Someone did have, it looked like a, no, I guess that was just Lorena saying hi.
I had one. I just posted
Sure.
in the chat, and great to meet you, Ed.
Hey, very nice to meet you.
This seems like a really big problem and a really full solution. So my question is, like, what's your recommendation for how we get companies to tiptoe into this? What's like the small steps you can take to get started? You mentioned notifications a few times. Is that your recommendation?
Yeah, so that's actually a great question. I think first off, just to make it clear, we have a fairly big roadmap. We're covering, just to be clear, things like .NET, the .NET suite, Java, which include, you know, and .NET, by the way, C#, VB.NET, ASP.NET, all that, MSMQ, all major relational databases, JavaScript very, very shortly. And also, incidentally, first stabs at compiled code support, so C++, as well, is coming in the near future. And then we have others like Python, including COBOL, which is going to be partner-based. So I don't want to make it sound like we cover every last scenario just yet. Our goal is to get there. That being said, I think the easiest way at the moment is pick a problem app, especially if it's in that category of languages that we support. And by the way, if you have one where you've got a really big problem, you really want us to come and solve it, and you're willing to sort of work with us on, say, a Python or what have you, we'd love to work with you on it, because these are not easy problems to solve. And frankly, every customer and every application is a little bit different. The more we do, the better we get at it. You know, our Java agent today is pretty spiffy, and our .NET agent has gotten substantially better, and quite frankly, a lot of that is due to customer interaction. That being said, pick an app. So let's start seeing what we can figure out, because the goal is that this is something that sticks around. It's intended to be there to catalog and maintain this information over time in this ever evolving and larger graph. So pick one app, start with that, and then if that works out and we show value there, go to the next one. And in terms of what you can do with it, I think the number one thing, just straight out of the box, like, it's so simple, but it's the one I think that is going to have the most value, is, you know, you got something that's important, put a governance rule on it so that you know if someone's messing with it. So talking about that real quick, we're just going to focus on, there's a bunch of top level nodes here. And so a quick description of how our data model works. We try to keep it symmetrical with the things that are discovered. So what we're using behind the scenes is a GraphDB, as well as a metadata engine as well. So we use a combination of a couple of different data stores, but the primary one is graph-based. And we're very heavy consumers of that. When you think about our graph, it has two primary sort of graphy directional elements. The first is a sort of conventional container relationship directed graph, you know, sort of traditional directed graph. And then there is the relational elements, which you can think of if you want to get, I know, Brandon, we were talking about somebody who loves the term bipartite relationships, right? Yes. But that's where you start to get that, where, you know, a great example is, for example, you have a base class, you have an instantiated instance of the class, and right there you've got a relationship that may lead to two instantiated instances, and then you'll see another one that goes up to a column that these two are interacting with for different reasons, all sorts of fun stuff like that. So looking at that really quickly, let's actually delve in. So what we have here is, I'm just starting to expand a database, and then interestingly enough, this happens to be our previous application, and the previous code base has no relationship to the current one, but it illustrates you'll see it illustrates, especially when Brandon shows you his really cool stuff, it'll illustrate some pretty interesting issues that you start to see when you can delve into this. So I'm going to expand the schema here, and we start to see, oh look, there's all sorts of tables here. And as I start to expand these tables, for example, we start to see it already begins wiring this up to methods and such. And if I expand this, I can start to see, you know, exactly how these relationships work. And if I actually click through, and this is intended to be a drillable, browsable interface, so I can start clicking through, and look, I get to start seeing more interesting things. So I can see that Java, this particular method right here, is specifically interacting with this column right here? Well, I might decide, you know what, this is a pretty important thing. This, by the way, is not probably the usual way you'll get to it, but you can browse through and do that. And what we can do is we can select this, and I'm going to say, you know what, I want to take a look at the audit history. Now, I just spun this up a few minutes ago, so there isn't much in the way of audit history in here, but if there was, you would see all the various, and there's a multitude of different types of fields and such that that we fill in here in terms of the values for each of these. And behind the scenes, we're actually maintaining in that graph, we're maintaining the state over time, not just the current state, but what was it the last time it was scanned, and so on and so forth, in sort of with differentials in sort of a time machine fashion. And we take the approach that we don't delete, we obsolete. So something might disappear from the primary view, but you might want to go back to the previous scan. And we don't have this implemented yet from a UI standpoint, but it's coming. But it's all there behind the scenes, and it is actually potentially from an API standpoint queryable and so forth. And we will expose it in the UI. But the idea here is we're maintaining all of this over time for all of this stuff. And when you see what all of this stuff means, you'll get an idea of the scope. But all right, now I want to go ahead, and I think I want to go and set a governance rule on this. So I'm going to select this. I'm going to hit new governance rule, and I'll just give it a name of Ned's test. And you know what we're going to do? We're going to take a look here and see what we've got. Well, we can do added, changed, deleted, referenced, dereferenced, and so forth. Now, the ones I, as an architect and software engineer, care about really are referenced and dereferenced. Not that added and changed aren't important, and there are scenarios where, for example, we're potentially partnering with a data classification organization or data classification company that does that type of software. Really impressive stuff that company has. But in that case, their added and changed, deleted are actually going to become very important in reference to sort of data classification scenarios and all that. But for sort of general use, referenced and dereferenced are kind of the big ones, at least in my mind, because that's where things come off the rails. And so, all right, I want to say, you know what, referenced. And what I want to see that is coming in new that might be from a second node standpoint, second node being the new thing that's referencing it. And in this case, we can select database, schema, table, column, stored procedure, application, source, et cetera. And I think here I'm going to select method. Once this is in place, once I apply this and it says success, it's now going to monitor this over time. It's going to be reported. If I were to go over to the governance tab, you'd see a list of hits, and it can be tied into other systems, like, for example, messaging systems and so forth, or it can be consumed programmatically. So we see an evolving scenario with people tying this into their DevOps pipeline, their CB, CDC, CD, all that stuff, wherein don't let it go from integration to master, don't let it go from master to build, don't let it go from build to deploy, and stop it in its tracks before it becomes a problem, right? So we think that that's going to become a big part of it. It's one of the scenarios that I happen to like very much. And then finally, we have this ability to take a look at something. So a lot of the time, you're not going to drill in here. And by the way, if I start zooming this out and I start expanding this, right, this gets, boy, does this get to be something pretty fast, right? And if I start, and and again, this is just two components I'm looking at here, right? And you start tying this all together and starts drawing all the lines and starts to look really cool. But ultimately, this is a lot of data to have to process and look at and so forth. So with that having been said, a lot of the time, you're not going to want to go and start doing this click, click, click thing. And by the way, getting all the state management to work in JavaScript was quite a challenge. By
the way, Kent has a question
sure.
in the chat. Can you actually roll back to the previous code level?
So we don't what we can do is we can show you what the past state was with regards to dependencies and relationships. What that could be enabled with is in conjunction with a build system. It could absolutely say, okay, well, this was the point at which it was good and the problem didn't exist, or that change, and subsequently could instruct that process. We don't maintain the source per se. By the way, depending on, and this comes back to Matt's question before about how it works. Matt raised a really good question, which is, how does it work? Well, it depends on scenarios. In certain scenarios, we look at source, for example. Others, it's static analysis, static bytecode analysis, maybe dynamic injection. In the case of others, it may actually end up being done at, for example, build time with for example, a preprocessor script and so on. So there's a lot of different ways it gets done. But what we can do is potentially tie that back to help with that scenario. Are we doing that right this second? No, but it's something I think we're absolutely going to investigate in the not too distant future as we get into these sort of integration scenarios with pipelines and such. Hopefully that answers that question for Ken. And one key note, when we look at this, we're collecting metadata. We're interested in the relationships. We're interested in what's going on in the database, what's going on between the application and the message queue and the database, between application to application, application to external API. That's all the stuff that we're interested in, including, for example, underlying infrastructural elements. You know, what VPC is it running in? You know, the association of these database elements to the actual server. So that we're getting as realistic a view of what these dependencies are, not just the potential that you might see by looking at, you know, a standalone analysis or that sort of thing, but what the actual potential deployed state really looks like. But we don't take data, meaning we're not storing the method itself. We can do it, but we choose not to. We don't want the actual code. We want a reference to the code. We don't want the actual data. We want the metadata for the database, meaning we don't want any of the stuff that's in the column, but we want to know about the column and its relationship. So, and that's a very clearly defined boundary that we're maintaining for a lot of reasons, not the least of which is we already have enough stuff here to potentially serve as a pretty serious security issue if it ever gets out. We wouldn't want to expand that by having actual sensitive data. So very quickly, the sort of final piece here is as we come in, you know, the most common scenario I think when you're actually looking for something, and I used one that purposely was going to return a lot of stuff, is to use search. And then from there, what's interesting is if you've gotten things that are related as we start to sort of drill into this, and as you can see, it's a bunch of stuff came back. It's interesting, it'll actually start wiring it up. But if you want to sort of shortcut that process, you can select one of these elements and you can hit calculated impacted nodes, and it will actually go and it will figure out, you know, what that relationship is. And in this particular case, if it looks like it's simplistic, that's because it is. This is the act. There isn't much beyond this. And that, by the way, is one of the other interesting things that we run into when we're doing some of this stuff is, you know, some stuff it has very simple, because in many cases we found like lots of dead-ended stuff. In other cases, you'll get much more complex relationships when you do that analysis. So the question is now, what's behind all this? And I'm showing you sort of what we call our basic user experience, which is really intended to sort of keep it simple. This is not where we get into sort of the hardcore, but it's where it allows you to start looking into this, setting governance rules and other things. What does it look like when we need to actually start visualizing things all up? And for that, I'm going to hand it over to Brandon for a second, and we'll sort of co-present on that. But I'll let Brandon explain how our rich client works. Our rich client is built on an application framework called Cytoscape and uses in order for us to be able to visualize the real all-up complexity and then be able to perform, for example, a pattern analysis and all that, as well as do really cool large-scale visualizations, we actually have to break out of the web browser into something where we have things like OpenCL acceleration to help with the rendering and all of that. And so what you're looking at here is exactly the same data I was showing you before, same database, same top-level application jar. But this is everything about just those two components. And essentially what this is the ORM layer, along with all of the various classes and methods that interact with the database in implementing that ORM layer, along with the database schema and all of that wire up. It's not loading all of these. He doesn't build it all apparent. So you can build one that's much bigger and scarier than even this. And Brandon, take us through what this is actually illustrating here all up.
All right. Excuse me. So this is the old database and ORM layer for our application. the old application that has been retired. And this is kind of the full view of both of those pieces and their interdependencies and relationships. And one of the things that we were able to find once we were able to do this level of visualization is you have some pieces that are pretty well intertwined. You end up finding them, they have some darker lines, connections. And as you kind of drill in, you can see that, you know, you have something like this that's an ID column. This was on the asset table on our old ingestion. And what we found is, as you kind of pull this out, you can see all of the different interconnections that it has to other places. And what these are actually foreign key references. So we had performance issues during ingestion. Things would take a very long time to ingest and decompose the application because there was a bottleneck here. Every time we would enter in something new, we had all these foreign key references. This actually spiraled out then into the application itself. At the ORM layer and
hey, Brandon, can you zoom in there a little bit? Because this is such an eye chart, but you know, you got to really sort of see this, you know, just all of the interdependency things that we're dealing with here. And, you know, we're looking at just one piece of this. So it's really something. And I think the first time, Brandon, we even got this up and running, we were utterly shocked because unfortunately, you know, using even the tools that come with, for example, the graph database engine that we're using, we could never even load enough of this into those visualization tools to even be able to see this. And so once we started seeing what was happening here, it is amazing. And when you factor in that, for example, behind the scenes right now, there's a whole bunch of other stuff. If we were to, for example, show, you know, the QA environment where it profiles the whole thing, it is shocking how enormous this dependency situation really is from a graph standpoint. And I got to say, Brandon, I get endless hours of enjoyment playing with this and you know, just seeing what the heck is going on in here. But the interesting thing is while this is a convoluted code base here, it was one that had to be reset because it got into that madness scenario where things were just getting added on top of already questionable architecture issues. Even one that's in good shape, even one that's clean, is still substantially complicated. And by the way, we're not even showing some of the stuff we're going to be showing soon at the micro level. For example, we're cutting off here at what's inside of, you know, the Java virtual machine, right? In the case of Java and this app. If we, you know, the next step is going to be, all right, well, let's watch what happens when we start talking about all the compiled code components. For example, the JVM itself. Or in the case of .NET, you often have applications where there's a mixture of dependent libraries. Some of them are .NET, some of them are straight compiled DLLs. And what's interesting is right now we can see exactly where that cutoff line sort of happens. But going forward, our goal is to show even more of that as part of trying to get the highest fidelity view at the micro level as possible, and then tying this all back together across the broad macro level so that you can see the interrelationships. So very quickly, we've got a couple of questions here from KB. This is really interesting. Let's say we perform this for a completely new application. Where does one begin to identify the bottlenecks, or how does one take action? Well, you know, that is a terrific question. And if we say by a new application, if we mean that one that's starting out, the first sort of goal in terms of analyzing problems that dependencies are creating is recognizing what constitutes sort of a bad pattern. So a good example would be if you start to see, for example, in your relational database, for example, just as a starting point, an over-reliance starting to form on a particular set of columns in a particular table where you're getting a lot of foreign key references that are starting to be created there. Or, you know, another good example would be if you're starting to see weird patterns, and this is something, you know, we noted in our old portion of our code base that was in .NET, if you're starting to see issues where it looks like you have things calling through things that don't sort of make sense. For example, it's surprising how even for a small company, very quickly, you'll start to see things like, you know, weird use of patterns. How many people, I mean, I don't want to cast any aspersions or anything like that, but how many people have encountered in their development career someone on their team who would learn a new pattern or some new cool thing? They'd be like, oh, you know, what was it? Is it? I always forget how many people. It's gang of three, whatever, you know, API facading, all that stuff. And they're like, oh, I'm going to do an API facade. And the question is, well, wait a minute, why would you do that? Well, if you can't see this starting to creep into your code base, it's a problem. And then I think in terms of the other starting point is identify key things that are really, you know, significantly important, and start monitor. Like, for example, if you have a column, or if you have a table, or if you have a class, or even just a method that does something very important, or it could be the service boundary. And you want to see if, for example, if I have a set of microservices and they're supposed to be going through a set of well-defined boundaries there, say from, you know, this, you know, they're supposed to be going through a specific set of API endpoints, and suddenly there's a new line that's evolved there. And where did that come from? Those would all be things where you'd start to see those problems. And I'll give you a really good example of where we caught a problem just on visual inspection. In fact, Brandon, I'll let you, if you want to, I'll let you explain it, because I think you explain it even better than I do. But it's such an obvious and small thing, but it would have led to a very big problem.
All right, so yes, as we're doing development and our CI/CD system, we have Jenkins set up. It scans the application each time we build it. And what we noticed is we actually had this kind of a new area form on our graph, and it hadn't been there before. And there was a much larger number of nodes than we would have expected for the amount of work that was done with that check-in. And what we found is that in our Maven POM, we had JUnit, we had added JUnit, and one of the test libraries wasn't set up correctly within the Maven definition, and it was including that in the release objects, or in the final jar for the build. So that would have been not great. Yeah.
Ungood, but by actually being able to see it, and there was a visual spot check, it was noted, wait a minute, this is much more stuff than is supposed to be there. And so we caught that. And interestingly enough, you just can't see those mistakes in the IDE. You can't see it. Not entirely apparent unless you really count bytes in terms of that built package. And so, for example, when we get to predictive analysis, you better believe one of the things I'm going to write some form of algorithm around is to say, hey, does this look like test libraries that are attached to this? You know, or does this look like abuse of foreign keys, or does this look like an overabundance of something or other, or and so on? Those are the types of things that we're going to be getting to. And some of those will get, I think, pretty sophisticated, but there's a lot of low-hanging fruit where, you know, it's just basic stuff that people can't see right now, but are, you know, making honest mistakes around that we can help with.
So the questions are coming fast and furious.
Yep.
Of course, we have to get on to Matt as well.
And I'm just going to answer one visualization that's being shown. This is not, I don't want to say this is atypical. This is a convoluted set of code, but believe me when I say that even a relatively clean, and we are only looking at one module that made up that application code base. So yeah, this is, it's a little more than normal, but believe me, once you add in, for example, if you were to profile your entire set of jars or what have you, you would absolutely see something as complicated as this.
Sam Miller has one visualization showing dependencies for a typical act. Is it showing something complex like Apple's logic OX?
That's what I mean. It's not showing something that's terribly, I mean, it is fairly complex, but it's not terribly so. When we get into showing like a compiled code and other elements, this will get even more insane. So that being said, I just will drop, I'm going to drop out because I got to hand it over, but I do want to, before I go there, before I hand it off to Matt, who's got, I think, equally important stuff to talk about. And by the way, Brandon, I'm going to need you to, it's really cool to watch those crazy visualizations, but I got to quickly.
Eric, by the way, has a very interesting thought there. Solar winds injection. Would you find it or not?
I would say that I'm careful to make comments about that kind of thing because let's just say that it would be interesting to like. I'll put it this way, and I'm not trying to purposely be cryptic. I just know that never throw. You know, when you live in a glass house, don't throw stones. But I certainly would be interested to see what that dependency map looked like for that application. I'll just leave it at that. And it, the thing is about injections, by the way, even down to things like return to libc attacks and all that. The real question is, there's always going to be vulnerabilities. There's always going to be mistakes made. What was going on architecturally that allowed the leveraging of that? Meaning there was a lot of other things that went wrong besides just the core injection attack itself. So I'll leave it at that. Just real quickly on how it works. It is essentially a graph-based system. It is what we call a relational directed graph. So it has notions of both directedness in terms of container relationships, but it also has this notion of referenceability across those container boundaries. It is symmetrical, uses a pluggable architecture. We're trying to keep the API simple. We're currently working on documentation on some of that where hopefully we catch where we're not as simple as we would like, but generally we're trying to keep them pretty simple. And in terms of the architecture, it is heavily reliant on the notion of pluggability. And this is both important for people who, both customers and partners, because the idea is if we don't cover something, maybe it's some specialized weird ORM layer that we, are never going to fully understand. You can extend our agents to handle that, especially on the Java side and .NET. And then on the back end, while it requires a little more interaction with us, there is also the potential to do that. And then finally, we talk where other people have really interesting stuff. We try to get that information directly. So for example, if you've got a CMDB or another system with a CMDB or what have you, we try to get that information. In terms of the actual implementation architecture, whether it's deployed to a container service like ECS Fargate or locally on a host, and a host could be any Ubuntu 18.04, 20.04 host. It's all containerized. We use the same pattern. Nothing too earth-shattering here. We do make sure there's a very clean separation of concern. And basically, we try to keep everything very ephemeral in terms of the implementation of the actual containers, keeping only minimal state on local storage for whatever that instance is that it's running. And the key there is that it's relatively easy to install the core product. So in the case of a host, it's apt-get install crosscode. In the case, and then updates occur with that, so it's all part of the normal servicing stack. And in the case of something like an AMI or whatever, you just redeploy the AMI when we do updates. And finally, to answer the question on data acquisition modalities, this makes it look a little bit. This isn't entirely accurate anymore. This slide. We have standalone agents, but now some of the standalone agents due to plugins now look both. They might do injection and all that. The basic gist of it is. We use whatever methods are necessary. And we have this notion of trying to tier them so you can turn them on or off depending on a particular environment. So you might profile a little bit more invasively in QA, and then down the road, if you decide to deploy into production, you might do something that's less invasive. We can take those and potentially splice those together to create a complete picture of what that application looks like in its as deployed state in production. And that's the reason, one of the main reasons we like this pluggability. Is it's going to allow us to do that as we go forward. So there's a couple of different ways it gets done. With that being said, I will stop for 1 second. By the way, how we use it, it's part of our test pattern. We review our own decomposed state, and then we implement governance rules around key entities. Any questions before I hand it over to Matt? Because I'm rushing to make sure I don't take too much of your time, Matt.
Yeah, well, we also have a raffle at the end so everybody should stay for that with 2 Amazon gift cards, but also CodeLogic is going to be offering free extended licenses. They'll provide a landing page in the chat for you.
We are? Oh, okay.
Yes, apparently so.
Well, with that being said, I'm going to hand it off to Matt. Feel free to drop me an email. I'm ned at codelogic.com if you want to discuss further. I love to get feedback, and for folks who would like to try it out, we're actively looking for folks to give us feedback and such on that. That being
not
said,
delaying you, Ned, but before you go, I think you have a question. DB Karen has his hand up.
Oh, I'm sorry. I'm sorry about that.
Have you guys thought about going 3-dimensional or higher dimensional?
Oh my goodness! Was this? I'm sorry. Did someone?
I didn't plant
Tony,
that, really.
You didn't plant this question?
Thank you, DB.
I'm sorry, but DB, the reason I'm laughing about that is this is now the third time this week, and at least one of these times it was planted by Tony. The answer is yeah, and how I'll very quickly discuss sort of the thinking around that. We actually have more data that we can collect than we're showing right now. We can make that graph infinitely more horrifying than you're already seeing it. And so, for example, one of the big problems is we can go down to code of line. We can show you this method calling this method. We can show you this method calling out to this API. We can show you the return path, all this stuff, right? And it can become this absolute horror show. The problem we're trying to figure out right now around, we have to sort of put the brakes on one of the efforts that was underway by one of our very smart engineers who he figured out how to do all this wonderful stuff. And I said, listen, we can't put this into the model yet because the graph is, we're going to break. It's not we're going to break our graph. We're going to break our ability to show you anything useful. So
you break your hardware.
Well, that's the whole OpenCL thing and using GGPU. But that being said, yeah, it's a very good question. And the way we're looking at it is what I like to call a 2.5D approach. So potentially we'll use 3D rendering. And this is a little bit down, probably late this year. But the idea is to come up with visualizations where you see that X and Y axis, but then when we get to the Z axis, you have to control the ordering, meaning you can't just have it be, you can't have it just be the Wild West. You see this problem a lot with the use of 3D visualizations, where it just becomes a star field with things going everywhere. So the way we're looking at it is how to approach creating a 2.5D view where there's a strict control where we can flip the axis and we can maintain the linkage, what is essentially a second 2D view, but with the linkage stretching into the 3D space, right? And then you rotate that.
Have you seen the movie Jurassic Park?
So every time I talk about this, everyone on the team starts saying, this is a Unix system.
Unix.
I know.
SGI.
Yeah, that was an SGI. It was an SGI
Demo.
IRIX. I was running IRIX.
Yes.
And it was a very cool demo. It was a real demo. They still have it out there. You can download it. But yeah, so the problem there is actually they didn't control the 3D access well. So it really didn't work in real life. It just became this big 3D thing to try to fly through. But we've got to try to do this in a way that's controlled. So long story short, drop me an email when we get there. If you want to tell us if we did it right or if we did it wrong, I'd love to have that conversation. But ultimately, yes, I think we're going there, whether we want to or not.
Excellent way to finish off. From 3D, we'll go to 4D and 5D as well.
Yeah, thanks very much. And Matt, hopefully I didn't take too much of your time.
Matt is up. Rock and roll.
Did we give Matt control? Oh, there we go. Great.
Yeah, I don't know if I have control, but I can take myself off mute. Let me see if I can get control here. All right. Yeah, looks like it. So I'll just jump over to this just to have it up. But
oh no!
All right, now I'm unmuted. Okay, cool.
There we go.
Cool. Yeah. So I do think it's a good segue. We kind of titled this "Easing Enterprise Evolution." So we have fun with our 3 E's in Kleeen. Can mean a lot of different things. I think we're playing around on the website too. What do we say? Engage. I don't have it right in front of me. Well, I should. Okay, so it's engage, envision, engage, export. So lots of fun you can have with 3 E's. But Kleeen Software is a company that kind of came out of just having the pain of doing front end development. So Mario, who is my partner in crime on here today, and is going to jump in for part of this and show us some cool stuff as part of what we're talking about here. And about half of the team, we're working at a front end design and development studio where, they were working for software companies as big as HP, a lot of people in networking space like Juniper and Cumulus Networks, financial services companies, HR companies, and building, serverless front ends that could then be plugged in through APIs to backend. So, a lot of people talk about cloud native microservices, architectures, et cetera. And what Ned's showing is just how hard it is to get there a lot of times too, because a lot of times you're dealing with crap like I was talking about, where someone's hacking together, Siebel going through Lotus Domino, which those are both outdated technologies, but still, similar hacks where people are just saying, oh, I can make this work, and stuff's kind of all strung together, especially when you've been building out your IT since 1966. And I think something like what CodeLogic is doing is just game changing in terms of just getting a handle on all that, because how are you going to get and go and refactor to something that's cloud native and modern and gives you the agility of something like microservices or connecting through a cloud native architecture if you don't even know what you're dealing with? So, getting that understanding of what you're dealing with, what data sources are connected to what, the APIs that exist, all that is really killer. And then, that's where Kleeen can be really helpful then in rethinking what you're doing on the front end. I was in consulting too, even just recently, working on something with a DMV of one of the biggest states out there, and they were moving their applications over to AWS, and we're getting it, kind of getting away from some of the mainframe technologies they were using in doing that. But on the front end, we were like, should we rewrite this thing that looks like it was written in 1982? They're like, nah, we got this thing called HATS from IBM. We're just gonna keep on porting over that mainframe code. Like, really? UI is hard. It's hard to really dig into that, especially because a lot of the monolithic UIs that are built out there, you change something, it's going to break something else, and it's all kind of strung together. So, we're really building more toward that cloud native API driven front end. But even there, when the studio is building stuff, what they found was, wow, people are hiring us to do things like go and build these custom workflows and front ends, and really, where the studio is focused and where we're focused is on data intensive applications, which you find more and more, and the more and more demand for them as people are getting data democratized. And people like to say that data is the oil of the 21st century. Well, oil by itself is just ugly black stuff that stains your clothes. You need to somehow turn that into energy. And I like to liken that to the workflows that we build at Kleeen. They're data intensive. You have all this value in the data that people are now getting into Snowflake or BigQuery or Redshift or places where they can actually get access to it. But you need to be able to take action on that to turn it into energy, to really impact the top line and bottom line. And that's really the type of workflows that we're building out. So not gonna help you automate the generation of the next Bumble swipe right, swipe left mobile app or something. It's front end to data lakes, AI, ML, networking, security, front office stuff in banking where you're dealing with a lot of equities, for instance, and portfolio management, things like that. And in building out that stuff in a bespoke kind of fashion where, typical process for the studio was, hey, I'm going to go talk to a product owner. They're going to tell me about, this crazy vision for what they have. And we're going to have this 3D map of the human genome that is all interactive and stuff. And it's going to be so cool. But to get there, you still have to have all this supporting infrastructure and stuff around your front end to make it usable at all. So while that's what they're all excited about, that someone would be talking about is like, that map of the human genome, or in the case of CodeLogic, like, hey, this dependency map is the killer app right here. And let's just focus all our dev resources on making that super awesome. But you know what? Beneath that, there's all these tables and charts, standard visualizations, because as much as you want to make a lot of cool visualizations, still business users mostly understand pies, bars, lines, graphs, line graphs, scatters, tables, things like that. There's standard presentation of data. So what the studio found is like, man, we're spending so much time like building out navigation, stuff like access control at the widget level and page level, internationalization, cross-linking data. or building out just these standard workflows like configuration screens. Great, you know, every product needs a configuration screen, but no one's gonna be like, oh wow, this is such a great config screen you made for me. Awesome job, guys. You know, it's just something you got to have. Or the workflows that are monitoring something, but then you want to dive in and investigate. So you got to make sure that data is extensively cross-linked. I mean, I was in my portal the other day for one of the biggest healthcare providers out there, and I'm like, oh yeah, here's this claim. What's the details on this claim? It's like, I couldn't get to it. I'm just clicking, like there's nothing clickable there. It's just like some dollar. Like, oh, thanks guys. You know, it's like one of the most frustrating things in user experience, but it's something that has to be done manually if you're not thinking about it. So what if we could automate all that and automate the workflows that take you from monitoring to investigation to acting on stuff, and then free up everyone's time so that they can make a resource allocation decision and say, okay, I got 10 people on my dev team. I could either have 3 front-end developers and 3 data scientists, or I could have another data scientist and just 1 front-end developer, and then I'll let this clean thing go and automate all the stuff. Like, who wants to build another table with filters and sorts and stuff? So that's the value and what Kleeen was built around. And you know, we've been built in a no-code fashion as far as building your UI, which there's lots of stuff about no code, lots of buzz about that stuff. And, you know, a lot of it is kind of crappy, I know. So don't love us in with the crap as far as that goes. I mean, part of it is just a lot of it is black box. So it's like, oh, you got to use our drag and drop components, and, you know, you can't get access to your code. So, you know, if I'm in a big organization, I want to prevent the next SolarWinds type thing from happening. I need to go through my automated tests, and I need to go through my source code analysis and static code analysis and all this stuff that I've built out in my DevOps pipeline to help ensure security and safety of what we're building. And I don't want some black box thing that's not going to let me do that or let me get to my code. So we start off as like, you don't know how to have to know how to build JavaScript to get just JavaScript in your repository. So, you know, where we have you build your application also isn't like this drag and drop stuff. So what one of our the folks that we work with, a guy named Dan Rosenberg, he's written like books called UI Magic, and he teaches at San Jose State on UX, and or actually that's called UX Magic, sorry. But he led UX for SAP, and his research has shown that if you start off with a semantic interaction design where you're building out something, you know, some people are like, oh, it sounds like a schema, in that there's things that are entities and attributes, or if you're speaking English, it's like nouns and adjectives. But, you know, build out what is your application about. So if it's like a application where you're trading equities, you have stocks, you have stock prices, you have ticker symbols, you have whether the recommendation is a buy, sell, hold, you have a firm that maybe is reviewing it, you have a position in the stock, and every position has a stock associated with it. Every stock has a ticker symbol associated with it. So you get this matrix of all this heterogeneous data and how it's related to each other. And that's really the starting point. And then once you have that, building out workflows goes really easily, because you already know, hey, this data can be compared to this data in these ways. These things need to be cross-linked. So then you go and you kind of build out your screens, build out your widgets. You can say, hey, this screen, this flashy, cool homepage, that's something I'm going to develop myself. So, you know, Kleeen, don't touch that. Just build me out a folder in the repo, and I'm going to check in my code myself there. But, you know, once you build out all those workflows, then you press go, and in 3 to 5 minutes, we go compile that into React. We also apply UX best practices and saying, what's the quickest navigation to get to this information? Let's make sure all these cards are equally sized. You know, what's going to be the best navigation for doing this? If a user's intent is seeing outliers, where are going to be the best visualizations for presenting outliers? Or if I want to see trends or parts of a whole, we kind of apply what's the best way to do that. And then you have a prototype that we spin out on the cloud. and that's where you go validate, and you can send a URL to business users. Now, this is in our environment, but it's with simulated data. So you don't have any proprietary data, you don't have any confidential information, but you can specify really realistic test data, like stuff that looks like your trade confirmation numbers or your order numbers, or the codes that your IoT devices might send off. So looks really realistic. It's not a mock-up like in Figma where you got certain hotspots and someone tries to click somewhere else and you're like, nah, you can't do that. It's just a picture with some hotspots, sorry. It's like a full React front end just with simulated data. And then when you're like, all right, I like this is good. I made some iterations with my business people. I'm gonna go push this to production. Then you put in your Git token, give us access to the certain repositories where you want to check in that code. And then we'll go do a pull request, just like a member of your dev team would. And we check in code first time, the full app. Other times as you're iterating, making updates, making changes, or there's an update to React that comes out and we want to push that, we're going to do a pull request just on incrementals. And you can reject anything that you don't want. You're like, hey, I don't want to do a React update on that widget or that page or whatever. It's just like getting code into your repo. If a developer was doing it, they do a pull request, you accept it or you reject it. And then we produce an API spec that basically says, hey, for every widget, every page, every action button, here's where you plug in your API. Here's what we're expecting from a Git input perspective. If you want to use GraphQL or REST or whatever you want to build your APIs, then plug that right in. For some of our customers that are coming from more of a monolithic development environment, we have some architectures too that we help to facilitate that, like something that Mario will show if we have time real quick, is something called Clean Snow that we developed that says, hey, don't learn how to build APIs to everything, just push everything to Snowflake, get that as your data hub for integration. And instead of, like one of our customers, one of the biggest automotive manufacturers, and they had stuff in their IoT solution in Postgres and MySQL in SQL Server. We're like, just push everything to Snowflake and get really good at building APIs to Snowflake, and then don't worry about APIs here, APIs there, to everything. That can facilitate the kind of evolution for some people coming from more monolithic structures. But the nice thing is we don't touch your data, we don't touch your APIs. A lot of people build out really good stuff at the data tier, API tier. Great, use that. But we're gonna generate the stuff that you don't want to and let you still have your code running side by side where you do want to generate stuff. So I'll just show you a quick demo and then kick it over to Mario too for some stuff. Let's see, where is my demo screen? All right, I see what's going on. Cool. So I think I'll start off with this portfolio management application, just because we are New York City, the home of finance, right? So might be some financial services folks on the line. If not, at least people can relate to that. All right, so here is kind of an overview screen where we're seeing a lot of clean generated widgets. A lot of this might look like something you generate with BI solutions, but a few key differences is we're letting you go right to data where it lies, go right to systems for integrations to take action on the data. And you don't have to have the overhead of having a BI solution in the middle, which just adds a layer of cruft to your solutions. But the cool thing is that for different visualizations, we'll give users different ways to look at the same data. So, we'll say, hey, a bubble chart might make sense for this, but you could also look at it as a table or different visualizations, ability to zoom in on visualizations. All these are standard generated things, cards that we standard generate. On this monitoring screen, we're monitoring one piece of information, and we told our UI this is going to be a monitoring screen. So we knew, hey, having a refresh button is great, having a refresh bar, being able to change my refresh time if I'm on a trading desk and I want to refresh every 15 seconds, or we have real-time refreshes coming later on this quarter. But all that, we kind of intuitively said, okay, that's something that makes sense given their goal. The cross-linking of data, being able to say, okay, I have a pretty big position in this stock. I want to go investigate that and look a little bit more closely about what's been going on there. You know what? This is getting close to my target that I had here. So I'm actually going to change my recommendation to a sell for my firm, and not having to go to a different system. Obviously, it's going to go feed a different backend system in the background, but we're having a button that may kick off a very complex action in the background, but we allow you to do that all at the API tier, make it very easy for the business user who says, hey, I want to sell shares. You already know what my position is in this equity. You know what my equity is based on where I am in the UI. You can grab all that information and execute a pretty complex action. Being able to, click over to things like tables easily. That's not a very detailed table, but if I go to, this screen, for instance, here, this is just our live mock-up. So we're showing a mock-up of a live newsfeed from the Dow Jones. But here's where you plug in your custom video player, whatever you want. But we're letting you in the mock-up at least put in animated GIF or a JPEG so that when you're validating your user experience, you can have something that looks real. But going to this page, you can see a lot more on the tables, and all tables have ability to filter and sort, put stoplight colors on different things, or apply filters that go across the whole UI, where I say, all right, I want to see only stuff that is by recommendation, and filter the whole UI on something like that. So that's one example application. I mean, here's one in the IoT space that we've been working on. Different views. This one was something more in network or in physical security. I thought I had another one up that was in order management, but that's not up. But lots of different use cases that we're helping people build toward. There are more of those data-centric use cases. And then, how do we build this? So our software is built with our own software, which is pretty cool. Actually, here's that order management app. I'll pull that up because it's kind of fun that this was built with the glass morphism theme that Apple's been putting out in the new Big Sur update. But actually, this looks better with a light kit. So everything ships with a light kit, dark kit out of the box, internationalization. But this was something that one of our developers was just like, oh, everyone's buzzing about glass morphism. I'm just going to go build this into the product a week later. So, just kind of proof point that we can stay on the cutting edge of UI and UX, so you don't have to.
I got to ask a question, because I remember we used to argue about skeuomorphism at Microsoft endlessly during the Vista into Windows 7 days. Tell me about, just real quick, what that glass, I can't even say it. The
glass morphism?
Yeah.
So Mario, as a more design-headed kid, what would you say?
What is the whole deal about that glass morphism?
Yeah, why are people excited about it? No, it's like rounded edges, like kind of see-through things, and
yeah, a lot of what has been going on with these different themes is that people remember when Bootstrap went out, right? It was quite popular. A few weeks later, all the products quite look the same. So part of what we do here is that we generate all these different colors very, very dynamically and with a wide range. So we have different themes, from material, that is what you're seeing on our own platform, to glass morphism that allows you to actually see things in a different way. So from dark to light, for example, if you have people who's looking at screen all day, like monitoring and tasks like the ones that Matt was showing, right? Those have to be usually dark, because it tends to be hard on the eyes to be looking at a white screen all day. So what we're really trying to do here is not only keep with the latest trends on design, but also to provide some functionality that could actually help our end users, right, to set apart their own products.
So,
cool, thank you. I didn't mean to take us off on a tangent.
No, it's good. It's good. And one thing I didn't mention is, like, building stuff where you get to a fully functional React app, like, takes about an hour to 2 usually for customers. I think this one here took about an hour and a half, because there was a good bit of data that we needed to come in and be able to link together. But if you think about the time it takes to actually go design and develop a front-end application. Usually 1 to 2 hours is pretty good turnaround. Here is that order management app. For instance, if I go to a customer, I can see a customer has, oops, wow, of course, I always have way too many windows open, but let's see, can I get back to where I just was?
So real quick question, when you say
Yeah.
1 to 2 hours, that's using your platform to
Yeah.
to do that? Because I was going to say that's just a general statement. I don't know about 1 to 2 hours to
Yeah.
build what you were just showing. So
Right. Yeah,
I think DB Karen has a
Yeah,
question.
I just want to say, have you ever tried to drink from a fire hose?
Yeah.
Yeah, I have. Yeah. No, actually, it's more a garden hose. I've done that plenty of times. So I haven't had access to a fire hose. Have you?
Well, I stole a wrench to open a fire hydrant. And I thought I was thirsty.
Yeah.
That's a New York thing to do right there.
Yes, exactly. Very New York. So, here's a kind of, once you build out that data model, you end up with a conceptual model. Like order is a very centralized piece of data here. Customer also, order name is just being referenced by order, but you can see a lot of this and you can say, oh, you know what? I forgot something on customer. I want to go create a new attribute on customer. You can do that right from the UI here. You can specify really realistic test data as part of the authoring. And yeah, and then you go build out workflows and you say, all right, for instance, on carriers, I want to see these particular widgets, like, carrier success rate. And there I'm going to be looking at the value of exceptions, the value of carriers. I want to compare those two things. So that's my data. Based on that data, I know that these goals are possible. You can compare parts of a whole, et cetera, but you couldn't see correlations. It's just not possible with that data. I may say that I want to see outliers and comparisons of parts of a whole, and it's going to give me different visualizations. And again, you can toggle between those visualizations in the UI, but it helps you kind of say, all right, yeah, this is going to make the most sense for my users to accomplish that goal. And then when you spell it all out, then, that's when you kick, hey, I want to build this thing. And you go say, launch the instant prototype, 3 to 5 minutes, and it builds. And then, this is not activated right now, but what you go and put in your Git token here and your repo info, and then it'll activate that push to Git button. And Mario, you want to kind of show what ends up in the repo real quick? Sorry.
Sure.
Yeah.
So yeah, let me take it from here.
Yeah.
Screen. This one.
I mean, I got GitHub up too, but I don't know where the hell I'm looking at.
You should be looking on my screen now, right?
Yeah, yeah.
Alrighty. So I already have some few things here. I have a different project. Making a project is really easy, honestly. So we build many applications for almost every purpose we want to test or try. So what I have here is the application we created, at least the one that I created, to integrate with Snowflake database. So while I already have a prototype, as Matt was showing, created, I already have it running live. Should be here on this tab with all the data, all the different things. It's also based on stocks, which I think is very relatable for everyone. And it was sort of easy to integrate as well in terms of data. So I'm going to go and hit export to GitHub. I already have provided some information that is required. And it's simple information. I need a token. I need to specify which repo, what is going to be the repo name, and what branch do I want to export that to. Yeah. And what this is going to create is it's going to go through a process that is going to go to that repo and actually create a pull request to that branch. Because we understand that committing code straight into your main branch won't be ideal. So the way we approach this is as if we were another developer. So it's not only a slogan, but it's also the way in which we export the source code to your repository. So as you can see here, I have in this very different version that I have already tweaked here and there, but I haven't exported it in a while. So what you're seeing here is the PR that Kleeen automatically created. So my screen might be a little bit too wide. So let me know if you cannot see what's on the browser itself, and I can zoom in. But basically, this is what we have. We have created a branch with a lot of files. So this is a very proactive developer with a lot of code. And while people tend to think that this is more verbose for being auto-generated, it's quite not the case. So this is really somewhat equivalent to what an actual team will have to do to create all the changes. So from here, your team can review, can approve, can merge, can take the entire ownership over this piece of code, test it out, whatever they need, and then they can promote it to develop or to main or whatever workflow they have on their end. So I also have, well, I have the prototype here running. All this is auto-generated data. So that is one of the cool things, right? We don't only generate the UI, but we also generate a backend that can be later on not only not discarded as you may imagine, but it's also going to be used to hook up the real data endpoints. So I'm gonna, so all these, what you're seeing here, this is the browser console, right? So all these corresponds to different queries that we need on the front end to fulfill all the different widgets and all the different information that the UI needs. So what I have done already is I have created a database using Snowflake. This is some of their sample data. So what I have here is the data that I need to fulfill this widget. So as you can see, this is a change in the DOE. So it has an amount of money and obviously the date for that when they close. So it's the same query that I have run here. So it gives me a timestamp, it gives me an average. And this is simple calculations on SQL over that database. So that at the end, what I get is a local project that I'm running, and I'm going to show you how did I do that and what needs to be done. And we're going to see the changes reflected on the UI itself, so that you can get an idea of how simple this is. Let me take a step back here to show you what we get back from the auto-generated backend. So this is an API request from the front end, no big deal here. And we get a response that has some data, has a widget ID, and has some other information, and has a result, which basically is a timestamp and a value. And this goes from 6 to 92, which is more or less what we should be getting on the UI for the values if I were to go here. So that should be roughly a match between those two. So I'm going to move into the project, and here I'm going to very quickly do like an overview of what you're getting when you do the export, as I didn't do that on the GitHub side. You're going to get what we call, and it's called a monorepo. That means that it's a single repository containing two projects. One is going to be the cloud project. That is going to contain all the React code, and it's a standard React application with code that honestly looks like it were handwritten by someone rather than being auto-generated. So it's completely standard. As Matt said, we're dogfooding ourselves with this, so we need it to be manageable and we need this to be maintainable. So this cloud is the front-end project that you can build. We have already a set of scripts so that you get the production distribution minified and everything you need so that you can plug that into your CI or CD and promote that into whatever environment you need, whether that's a testing environment or production, if that's the case. And we also have this other project, which is called API, pretty straightforward. And as part of this, we have an entire backend that is self-generated. And there's a special place where we place what we call custom. And custom is where you can actually go and modify, and you can go and create, and you can go and do what you really need to do to connect to all the different data sources that you may have in your product. So I have already created a connector for Snowflake because while this is great database, it doesn't expose API. So if you have an API, you don't have to create a database connector and all that work. If you were to need it, then again, this is a clear example of how straightforward that is. This is just following, it's very simple. It's following the guidelines from Snowflake on creating a JavaScript connector. So I'm going to skip the details of the connector itself, and I'm going to go to a widget. this code here, and let me, how do I move this? Okay, so what we're seeing here is the code that has been auto-generated that matches this widget that we have here in the UI. And I'm actually gonna, this one, changing those. So this is the widget. It's grouped by timestamp. Here's the average, the value, how it's aggregated. So it has some indications. It tells you that it's a positive, negative. All the data generated here is positive. So with the real example from Snowflake, we can see that we have positives and some negatives values. So this is going to get more interesting once we connect it to the real data. So as with all demos, I'm going to do some little tricks, and I'm going to grab some of the code that I have already here, which is sort of the work you will need to do. And you will see that right now it says return not implemented. That is like the flag that will tell our system, hey, the user is not sending any data. Go and use the auto-generated data. So the goal here is to replace these not implemented flags with the real data. So how do you do that? It's pretty straightforward. What I have here is a call to the Snowflake connection. If you were to have, if you were to have an API, then it will be like a fetch or something like that, where you call the endpoint. In my case, again, it's a Snowflake connection. I get a result that I then map into what I need. I know that I'm getting from Snowflake query a timestamp and an average. Then I do this. I massage this information so that it matches the structure that I want, which is the one that I already saw, that I already showed you on that API call, which is basically an array of results that has an array with the timestamp and the value itself. And once I do that, then I have a catch here in case something fails. It returns the sample data, but this should be straightforward. I have some other options. I can send more format details. I can send information for crossing. So I can send a lot of other information. But the key point here, and for this example, is precisely the result. So I'm gonna save this. We have a developer mode for the project. So right now I'm running a server for the front end, and I'm running a server both locally for the API. So I will need the API server to reload. It's doing its magic. Then I'm gonna go and reload the UI. And we're gonna be seeing a change here, not only visually on the graph itself, but also in the data response that is gonna match what we have here on Snowflake. I gotta say, yeah, well, okay, reload. So let me, oh no, but it reloaded the, it told me, did the refresh. Let me reload this and see where we got the data.
Yeah.
I just want to say one of the things I really do like about what you've done here is sort of the model-driven pattern, where that's something that seems very much something that's sorely needed in the JavaScript world. You know, things like MVC and all that are common in places like Java and all that. But you know, having that here, I think is really great.
So here it is. As you can visually see, the chart has changed, right? Now it has not only the positive values, but also the negative ones. The response is shorter, is different from what we were getting. And those are the values. And the values actually matches what we have here, right? If you see the numbers, those do a match. There's not a negative value per se here, but remember that what this is showing is it's a change, right? So whether it went up or down based on the previous closures. That's why we get a negative here. And if you go to any point of this, you will see this formatted already with the money symbol and all that according to what we provided on the backend. So it is a really, really straightforward. This is really do and repeat. I like that about this in terms of feeding the UI. For every widget, there's going to be an API that is going to serve the data. And it's as simple as that, as replacing the default not implemented with whatever you want from your data sources and having hook it up. We also have some cool stuff going on. It will take more time for me to cover that. We have a GraphQL server on, that is the one that is running locally. So there's a lot of cool stuff and for you to explore and continue working on And again, as mentioned, this is something we're using for ourselves. So we have really invested a lot of time in the quality of what's going on and what's going out from the platform to the repositories themselves, making it so that we can leverage that to continue developing the product.
Awesome. Thank you,
So,
Mario.
Yeah, this is
any questions, I'll be happy to answer.
I just think this is a really significant and serious step forward, especially in building these types of interfaces and applications in the web world, because there's a lot of stuff here that, when done just sort of in straight JS and React and all that, is really a lot of work, a lot of time consuming work, and it's prone to very, the best way I can describe it is just sort of a lack of coordinated patterns. So you end up with, you know, team over there is doing it this way, team over there is doing it that way, and they're completely different. And in many cases, you know, we see the whole proliferation of competing patterns even right now, just in React land alone, where, you know, the folks at Facebook are doing this thing. I mean, we had this problem just trying to figure out which state management model we were trying to use. And so I think someone's sort of taking this by taking the whole notion of having standard tools. We adopt this, and you know, full disclosure, our intention is to adopt this on our side. This is something where, I mean, it is an important, I think, move forward, and I'm just glad to see that someone's taken this bull by the horns.
Yeah,
this is amazing stuff. As I said at the beginning, we're showing emerging tech as it is built in front of you, literally. Mario and Brandon and Ned and Matt are in the engine room every morning building this.
I do actually have a question for Matt and for Mario. So, you know, in the world of sort of languages, especially front end, you know, delivering SPAs and browser applications and all that, this is kind of a big thing to bite off, because it really hasn't been dealt with, you know, until what you folks are doing. There really hasn't been something that's trying to do this way. And what made you want to tackle this problem, you know, in terms of you mentioned some of the stuff, you know, from your past, but what made you want to tackle this specific problem and do it now?
So yeah, that has a lot to do with the work we have done, right, through our entire careers. I already lost the count of how many dashboards I have built, how many visualizations, and it was exciting. I mean, like the first two dashboards, like, oh wow, I'm gonna do this visualization. Oh, I haven't done that. But given time, it's very hard when you have teams to keep them engaged, to attract talent, to retain talent. If you're doing the same things over and over and over, and it takes time. Right now, I'm so excited, honestly, that building apps is so easy for me now, and I can just do a couple clicks here and there that takes me less than an hour because I'm already familiar with the application, right? And I can get an application that I'm fully aware that it will take me 6 months with my good team, and I've been blessed for having great resources that I can work with. But I know the struggle and the pain when you want to implement or you need to go out to market with a new version of your tool because you want to stay ahead, because you want to become competitive. And not everybody has that great chance of building great UI out of the box. And the JavaScript world changes a lot, right? So as you were saying, state management, if you get into that in React, it's gonna take you a while to get an expertise to do it right. So we have done all those mistakes, and we figured that making this in the right way is what we must do. There's simply no other way to keep moving forward, right? Than making it right, because we figured that we were capable of doing it, and definitely we feel the pain, we feel the struggle, and if there's value for us, then there's going to be value for many other people who is in the same spot.
You know, what's interesting is in the JavaScript world, it's become sort of the de facto standard language for building front-end experiences and a lot of other things, but front-end experiences. And it's strange because it's not nearly the easiest, at least prior to this and what you folks are building, it's not even remotely the easiest way to do it. But because of the browser and the broad acceptance of that as a platform for delivery and consumption, you know, it's just fascinating to me that some the things that we could do very quickly in certain, you know, sort of the rich client world, but you know, you don't have that broad acceptance. So you don't have that default browser everywhere, and it's amazing that it's taken a while before I think somebody like yourselves came along and figured out this problem. So, well, thanks for doing it, because I think it's a very, very badly needed thing. And, you know, I look forward to seeing how this changes stuff from a broader industry standpoint. And hopefully, yeah, we stop remaking dashboards over and over and over again.
Well, I hope that was informative and instructive for everyone. As I say, as I started the whole process at the beginning of the event, we're here to provide new and completely different technology that we haven't seen before. Anybody has any other comments, you're welcome to make them or as a comment before we leave. But I was going to raise a glass to Matt, and I don't have anything in it yet, but I will fill it in a short while. To Matt and Mario and Brandon and Ned. And there's some folks are yeah. I mean, I have it ready.
I unfortunately am just sugar and caffeine.
I'm doing the dry January, almost done.
But as I said to everybody, we're going to have the office open once we slay COVID. And there's going to be a party down here to celebrate the slaying of COVID, as well as the productivity that we have brought forth during that lovely time. So with that, I thank everyone, and I thank everyone for some really cogent questions as well that we have noted in our repertoire. So have a lovely evening.
You doing the drawing on
wait,
yes.
Murat,
yes. Where's the drawing?
Everyone sat through all of this so they could do the drawing.
Like, we did this for nothing.
Yeah, on behalf of CodeLogic, I took everyone's name and I did a random raffle, and I got 2 winners. The first one is Don Bernsley. The second one is DB Karen. So I'm gonna put my email address in the chat. You can get in touch if you want $50 to Amazon.
Yes.
I will send it out tomorrow.
Thank you, Jennifer. This is Dawn. I just unmuted. I'm not gonna undo the video because I was making dinner, and so it's a
no worries.
Thank you. I'm very excited, Jennifer. I'll follow up with you. Thank you.
Yeah. And I'll just mention, you know, if anyone wants to use Kleeen to prototype and, you know, build some prototypes out, just write hello@kleeen.software. It's on the website too, the web form, and we're happy to kind of give people an account to give us feedback and build some cool stuff. So, yeah.
And to DB, we will drop me a line because we'll talk further about in fact, Brandon and I have just been going back and forth on, you know, how to answer that question better in the future.
Well, actually, I have something, and I'm just going to leave a teaser, and it's called Kuhn's numbers. You'll hear more about it when we discuss it later.
Outstanding. Well, it was a great question. It's a pleasure talking with you, and thank you very much, everyone. And hey, Matt, thank you for your stuff, and Murat, thanks for hosting it.
All right.
Go Austin, Texas.
All right. Yeah. All right. Well, hanging in there. Go New York City.
Thank you, everyone.
Thank
you.
Take care. Bye-bye.
Bye.
Thank you.
Bye.
Bye-bye.